Hello everyone, Reginald Scott here, aka the Bike Doctor, as some people know me. Today we're going to talk about bearings and whether you should buy ceramic bearings. Now, if you listen to the manufacturers of ceramic bearings and the cycling magazines who review those ceramic bearings, and if you watch the Pro Tour, who a lot of the teams use ceramic bearings, and if you follow some of the big cycling YouTube channels out there which dominate the scene of cycling, often presented by ex-professional cyclists, they will all tell you what you need is ceramic bearings, because without them you'll be at a major disadvantage, because ceramic bearings roll faster, are more efficient, and they last longer. Wow. So that must be why they cost sometimes 10 times as much as standard steel. So that concludes this video. Let's all go buy ceramic bearings. Oh no, wait, that's not actually true. In fact, it's completely wrong. So, why am I saying all of this? Let's talk about bearings. So we're both on the same page, and we both know what I'm on about. Just in case you don't know anything about bearings, let's look at a little diagram of what a bearing looks like. So here we have our bearing. We've got the balls in the bearing there, which are the little round bits that roll around inside the bearing. We've got these blue lines which represent the bearing cage. And the bearing cage spaces out the balls and prevents all the balls from dropping down to the bottom. Men will know about their balls dropping. So the cage prevents the ball drop, and the balls also rubbing together uncomfortably and creating friction. You'll also know about that if you're a guy. And we have the inner race and the outer race. Not race as in what colour you are, race as in the two places where those balls run. And to demonstrate the race a bit better from a side view, as if you cut through the bearing, you can see there the ball is nicely seated in between those ground cutouts of the bearing, and that prevents the ball from moving around all over the place. And here I have my talking points for today's video. So we've got roundness, we've got lubricant, hardness, cage material, RPM, which is rotations per minute, heat, impact, and load. So these are all issues of ceramic and steel bearings. So now we know the construct, or the representation of how a bearing looks like and what's inside a bearing. Let's talk about whether you should get these ceramic bearings. So let's break down what they say first of all. They say that ceramic is much harder than steel. That is true. Okay, great, fantastic, we're doing well so far. That's true. They say that ceramic balls deform less when under load than steel. That's also true. Wow, okay, we're doing even better. They also say that as ceramic is so hard, it doesn't erode or wear down as fast as steel, and therefore it will last longer. You know what? That's true as well. But if all that's true, then why do I personally use steel bearings? Why don't I get ceramic? And why don't I sell them? Well, where I come from, in the robotic industry, we used both ceramic and steel bearings. We used our steel bearings in the robot arm itself that was doing all the motions, picking things up, welding, moving very quickly from place to place. They were all steel bearings, and that was because they're cheap, or cheaper. They're very, very precision. Top quality steel bearings are actually higher in quality and precision than top quality ceramic bearings, because top quality steel bearings are made by the biggest, best manufacturers in the world, and the top quality ceramic bearings are made by little mom and pop shops that are only usually making them for the cycling industry. And I'm talking specifically about hybrid bearings, but I shouldn't reveal that just yet, because that's the clincher. So So we used to use steel in our robots. They're easier to replace and they're actually harder wearing. Here's why. The fully ceramic bearings we used to use were ceramic on the outside, ceramic on the middle, and ceramic on the inside, with a ceramic cage and ceramic balls. It was completely made of ceramic, and they would be used in fans, electric motors that run at very high RPM, so several thousand rotations per minute, little electric fans spinning away, cooling down the CPUs and the parts of the computer brain of the robot. Because electronics gets hot, and when electronics get hot, they become less efficient. Now, the great thing about those ceramic bearings that we used to use in electric motors is they can run at extremely high RPM for a prolonged period of time with very little lubrication, because they simply don't need it. They're not under load. They're just spinning in free air, if you like. And because ceramic has fantastic heat dissipating qualities, it doesn't conduct a lot of heat, they don't get hot. And if a steel bearing gets hot, it starts to expand in various different places. The balls will get hot first, and then the race will heat up slower. So the balls start to expand, and then they start to rub against the race the wrong way because they're too big, and then you lose the efficiency of your steel bearing. So we used to use fully steel bearings and fully ceramic bearings. But here's the problem. The bearings that you have in the cycling industry, the ones that somebody put in your bike, or the ones you want to get put in your bike for several hundreds of dollars, sometimes 10 times the price of a steel bearing, are not fully ceramic bearings. They are hybrid ceramic bearings. What's the difference? Well, a hybrid ceramic bearing has got steel outer race, steel inner race, polymer cage, which is basically plastic, and ceramic balls. So in a hybrid ceramic bearing, the only thing that's made of ceramic is the balls. Now here's the problem. They're rubbish. And the reason that they're rubbish is because of this. So let's go back to what was said before, which is ceramic is much, much harder than steel. That's correct. So when you have ceramic running on ceramic, so a fully ceramic bearing, you get a much more efficient bearing. When you get steel running on steel, especially high quality steel bearings, which have got much finer tolerances, you get a very efficient bearing, especially one that's efficient under high load. But if you put a super hard ceramic ball into a softer material like steel, you muck that up completely, because that very, very hard ball pressing into that steel does two things. Number one, it deforms the steel more, because you have that very, very hard surface of the ceramic ball, which doesn't deform, pressing at a very, very small surface area into that steel race, which creates a lot of drag. Okay, it creates a lot of friction because it's pressing in, and the steel has to deform because the ball, the ceramic ball, can't deform. It's much harder. And if you then take that, right, and you start riding that down the road, that ceramic ball starts to wear away your steel race incredibly quickly. And if you look at a chart of the efficiency of a high performance ceramic hybrid bearing versus a steel bearing, the steel bearing, the efficiency and the wear stays fairly stable all the way across until eventually it starts to wear out, and then the efficiency drops off. With a ceramic bearing, it drops immediately. It takes a nosedive straight away, because those super hard ceramic balls are wearing away your steel race. So over a very short period of time, they ruin your bearings, or the bearings destroy themselves. Now, the other problem with hybrid ceramic bearings is that polymer cage we talked about. Now that polymer cage actually creates more drag than the steel cage in a steel bearing. So that polymer cage is there for a reason, a number of reasons. Firstly, these steel bearings are made by huge manufacturers, experts in their field basically, like NTN and SKF, who make these big industrial bearings. They're the ones you want to go for if you want to buy yourself some good quality bearings. I'm a big fan of NTN, I like NTN bearings. Used them a lot in industry before, but I use them now in bikes if I can get hold of them. And the reason is that these big manufacturers use quite advanced manufacturing techniques, and so those metal cages are much easier for them to make, and they're actually folded metal inside there, little folded rings of metal that interlock with each other, and that's quite hard to do by hand. Whereas and sometimes they're riveted as well, they actually put rivets between the folds of metal and rivet those cages together, and it's something you literally, well, you can do by hand, but it would be very, very difficult. So it's advanced manufacturing techniques. The ceramic hybrid bearings that are made by these bicycle companies, they're not as advanced. So it's a lot easier to have a printed polymer cage or a stamped polymer cage, and then literally just take the ceramic balls and put them in the polymer cage by hand, which they can do. And if you've ever looked at the production facility of a ceramic bearing manufacturer, which you've probably done on a leading YouTube channel, you'll see a lot of people, usually women, just putting the balls into the cages by hand. It's not an advanced manufacturing technique, but those cages add a lot more friction to the balls, so they run less efficiently. And when tested, when a hybrid ceramic bearing is tested against a high quality steel bearing, under load, they actually perform less well. Now, what most people see when they're discussing bearings is the shopkeeper or the guy on YouTube or whatever will take a steel bearing, spin it, okay, and it will stop spinning relatively quickly, and then they'll spin a ceramic bearing, it'll spin for several seconds longer, and they'll say, look at that, you know, the spinning so much longer, it's so much better. It's not a good test, and the reason it's not a good test is that bearing is not under load. Okay, load is the weight on top of that bearing bearing down on the bearing. Okay, and that load is really important. So when they properly test bearings, not like these ceramic manufacturers do, and not like they do when they're advertising the bearings, they won't run a proper test. They'll just show you that and expect you to fall for it, which granted a lot of people do. When they do proper testing under load, they actually find that the steel bearing comes out on top, and the reason for that is what we've discussed earlier, which is that the two steel ball, the steel ball and the steel race pressing against each other, they are of equal hardness, so they don't wear each other out and they don't press into each other as much, whereas the super hard ceramic ball under load with the whole weight of the rider on top, maybe 70 or 80 kg, plus the bike another 10 kg or 7 or 6 kg, you know, you're looking at 90 kg sometimes. All that is weighing down on your bearings, and that ceramic ball is being pushed into the softer steel, digging in, and it just creates a much less efficient bearing. So under load, steel actually wins if you look at the data, and the data is below in the videos below if you're interested in watching yet another long video on that. So we have discussed the cages, the racers, the balls themselves. So if this is the case, and it is, unfortunately, reality check, this is true, then why do the pros use ceramic bearings? Well, it's the same as anything that the pros use, and I'm going to do more videos on this subject, and I'm going to examine a lot of the stuff that the pros use. And actually, with your own money, you can go out there and buy stuff better than what the pros are using. The stuff that the pros are using is sponsored, okay? Most of the time, the bikes are sponsored, the wheels are sponsored, the components are sponsored, and if they're not sponsored, they're given away for free a lot of the time, because the marketers want to show that the best cyclists in the world are using their products. That does not necessarily mean that the best products are used by the best cyclists, okay? And the problem with this is that if those cycling teams are not using ceramic bearings because they're being paid to. If they're choosing to use them, and not every team in the Pro Tour uses ceramic bearings, and for good reason, then the reason why is they're as ignorant as a lot of the everyday people that are buying ceramic bearings. They have fallen for the same marketing, and rather than take the risk that their riders might be at some disadvantage, they go out and buy ceramic bearings. And the funny thing is that a hybrid ceramic bearing will be roughly as efficient as a high quality steel bearing for a short period of time. So they won't notice any decrease in their riders' performance as a result of using hybrid ceramic bearings. It might be a little bit less, but generally it's about the same. And because they change their bearings in their riders' wheels and hubs and bottom brackets so regularly, they never see that wear occur that a normal everyday person who purchases ceramic bearings would see, because they literally don't spend enough time on the same set of bearings. They're constantly changing the bearings, just like the teams that use steel constantly change, so that they've got the very best, highest quality, newest bearings inside their wheels for every single race. They're not stupid, that's what they do. So if you want to replace your bearings every single ride, you could do that, and you would have the most efficient bearing out there every time you ride against your friends. But most of us aren't going to do that because it's kind of crazy, and it would be hugely expensive, especially if you were doing it with hybrid ceramics that, as I say, can cost so much more than steel. So my recommendation is this: much of the friction within a bearing actually comes from the grease inside the bearing. The grease is the stuff missing from this bearing here. We pump it inside the bearing, and it's a viscous solution, it's a viscous liquid, sits inside the bearing, and that grease protects the bearing from bad weather and from debris and dirt and water from rusting up the bearing and destroying the bearing. You need grease inside your bearings. However, if you want to go faster on race day, you flush your bearings out with a degreaser and you apply something like this, which is a bearing lubricant. This is my bearing lubricant I sell in my shop, bike.Worth Performance Lube. It's better than the competition because it's half the price. You get more of it than the other bearing lubes out there available on the market, and I've actually mixed this myself to get the perfect consistency that is retained in wet weather better and also reduces friction to the top level. So my bearing lube is the bee's knees, $15 if you want to get it in store. If you're elsewhere in the world and you'd like to try my bearing lube, then just get in touch and I'm sure I can send you a little bottle, postage and packaging and all that. It actually works really, really well. So you race on the lightweight bearing lube, okay, like Alberto Contador's mechanic would put in his bearings. You race on that lube and it frees up your bearing to move as quick as possible, as freely as possible, without the drag of the grease. And then when you finish the race, maximum 2 weeks later, I would recommend you put the grease back in your bearings and you continue to train on grease. Because if you continue to ride with the lightweight lube, eventually that lightweight lube will dissipate, it will come out of your bearings, it will leach out of your bearings, and you won't have any protection on your bearing. Water and dirt will get in and it will destroy your bearings. So it's only for short-term use. I know one guy, he bought more expensive bearing lube from a different manufacturer. He used it in his wheels all year round because he was advised to do that by the seller who sold it to him. Foolishly, the seller didn't know what he was talking about, and within a few months his bearings were destroyed. They literally fell apart because the lightweight bearing lube is not designed to prevent that dirt and that water from getting in, but grease does. So ride on grease all year round, race on a performance bearing lube like the one I sell in my store. And that way you will have better performance from a steel bearing than you ever will from a hybrid ceramic bearing. In a perfect world, you could use fully ceramic bearings on your bike, but unfortunately you can't because of impact. And the other thing is, of course, dirt. When dirt gets inside your bearing, especially if it's sand, which is very, very hard, it's crystals. Crystals are very, very strong, very, very hard. They make little chips off your ceramic balls, and those little ceramic chips make more ceramic chips off other balls as they spin around inside your bearing, and it basically destroys itself. It's a chain reaction. Once one of the balls becomes damaged, they all damage themselves very, very quickly because they're constantly rolling over that debris that's sitting inside the bearing. So you'll notice that ceramic bearings fare much worse, much more quickly when dirt gets inside. Steel is much more resilient. You may get pitting of the bearing, but it smooths itself out over time, usually with that constant rolling motion, and you can run steel bearings for absolutely years, and they'll run and roll to a reasonable level even after being slightly damaged, far better than a ceramic or hybrid ceramic bearing will once it becomes damaged. So there we go. Hopefully that answers all the questions. Hopefully that gives you the information you need to go out there. So my recommendation is, and you don't have to listen to me, watch the videos below. A couple of other guys talking about similar subjects. I want to link those 2 videos in because they are excellent. And if you're still on the steel train, if you like, the steel is real train, then go out there and do your own research. But what I would advise is skip the first 2 pages of Google results, because they are posted by the manufacturers, by people sponsored to talk about that stuff, and by people who want to sell that stuff to you. Feel free to share this video with your friends to get the word out there so they don't make the same mistake, or maybe not share this video with your friends and you keep it to yourself. Get yourself some really high quality steel precision made bearings, fill them full of bearing lubricant like this before a race, and beat the pants off them, because they'll all be riding around on damaged hybrid ceramic bearings that they've spent many hundreds of pounds on, and you can be all smug and have a big smile on your face knowing you spent less and actually achieved more. So, thanks for watching, and as always, stay safe. Thanks.